Okay, good evening all. Today we will learn regarding the
Good evening.
quantity takeoff in, in Civil 3D. I will share the screen now. My screen is visible to everyone.
Yes, sir.
Uh, until now, we done the taken the survey data from SRTM and we created the surface. And after that, we created the alignment. And after that we done the vertical profile and we done the horizontal and vertical curves. After that we done the assembly. You can see this was assembly we developed. After that we model the corridor, right? You can see after modeling corridor this will be uh, invisible, right? After that you can see this is a plan profile of all 51.409 kilometer. Okay. Then after we will go for the quantity takeoff. Before that, we need to develop the corridor top surface and datum surface. For that, go in the home, activate tool space, go in the prospector. Under prospector, click plus icon of corridor, and then click right click on the design corridor. Uh, Click on the properties. In that you will go in the surfaces, right? In the surface create the new surface, name that surface as DC top design corridor top surface, and in the overall overhang correction you will select top links, and again create another surface, name it as DC bottom. For overhang correction it will be top bottom links. Select the DC top, and in the about rectangular portion you can see add data. In that select links, then select top, specify code as a top, then click plus icon and select DC bottom, and in the specify code you will select datum as a specify code. Click plus icon, it will add, then apply. Then you will go in the boundaries. You will get the two surfaces, top and bottom, design corridor surface. Click right click on the DC top, uh, click on the corridor extend as a outer boundary, like that for DC bottom also. Then click apply. It will ask to rebuild the corridor. Click on the rebuild corridor. It will build the corridor. Then click OK. Now you can see in the surfaces uh, there are three surfaces. That first one is existing surface, and the second one is DC bottom, and third one is DC top. After that, the important setting is that uh, quantity setting, that is there in the setting tab. You will go in the setting, then you can drop down, click the quantity takeoff right here in this quantity takeoff plus icon. In the quantity takeoff criteria, click plus icon. Then in the on quantity takeoff, right click. It will ask, click on the new. It in this we need to add the material. That this step is known as material definition, right? In that you will click add new material. Name it as earthwork, right? I will name e dot work. In that in the quantity you can see, in the quantity type you will select earthworks, right? And cut factor fill factor will be as one only. After that you will select the in the define material you will select the surface. Right in the surface, we will add the existing surface. Select surface as existing surface, then click plus icon. It will add another. We need to add the DC bottom, right? Select the DC bottom and click add. Now for earthwork quantity, we will need the base and compare surface. That existing surface is a base surface and DC bottom surface is a compare surface. Like that, we will select the condition, then click apply, click OK. Right? Now we will go with sample lines. For at the interval, particular interval, we need the earthwork quantities. For that, we need to develop the cross sections. To develop the cross section at each particular interval, we need to define the sample lines. Right? In the home tab, you will go in the sample lines. Click on sample lines. It will ask to select the alignment. You will select the alignment center line. Then this pop-up window will open. In this, you can see this pop-up window. In this, uh, in the select data source to sample, you will select existing surface as existing ground style. It does not need to select any. It will automatically select existing ground. For design corridor, you will select finish the ground as a style. For design corridor also, for bottom and top, we'll select finish ground only. Then click OK. Now you can see this top up bar will open. In that, we will select the range, sample lines by the range. Okay, it takes time. We will wait. In that, you can here we'll select by range of stations. You can see. And then this pop-up window will open. In that, we will select the left side width and right side width. Right. For that, we will select 30 meter as a from center line. We need to define how much levels or cross section width will be there in the cross sections. That will define in this left swath width. Right. I will define my 30 as a left swipe width and right swipe width as will be 30. Based on the ground profile, we will define this. If the more filling is there, we need define more the cross sectional width. Right after that, we will define the sampling increments. That for I will go with the 200 as the alignment is big. Right, I will at the range start and range end, I will make it at the true. I need the cross sections at the start and end also. That's why I make the true. Right, then click OK. Then will it will you can see this pop-up bar will display. In that, specify station along baseline. Right, you can specify any baseline under the alignment. You can see I am specifying this point. Right, I'm click right now. Then after click OK. Now we can see sample lines were created. Right, now the width will be needed more. That the sample lines are within this boundary. No, we need the sample lines outer to this boundary. That for that I will delete the sample lines first. Select similar and delete. Right, I will go with the same sample lines. Select the alignment and by range of stations. In that, I will input 50 meter as a width and 200-meter interval. Then click OK. Then overwrite all. Click OK. Now we can see sample lines were created, right? These all sample lines. You can see these all sample lines. This blue line, right? After that, we will go with the creation of cross sections. In the Home tab only, there is a section views. Click drop down icon of that, then create multiple section views. In that, we will select the alignment and sample line group name, and I will station range. Now I need the whole package. That's why I'm selecting automatic. Then I'll click next, then next, next, next. In this tab, you will select already it is the style already we selected will automatically select. In this, you will for the band data, you will select the first is the FG elevation style, right? In the FG elevation, we will select the DC top, right? Both surfaces will be DC top, and for EG surface, we will select existing surface, right? Both will be existing surface. For the offset, we will select DC top only. And for cut fill, we will select surface 1 as a DC top and surface 2 as a existing surface. After that, click on create section views. It will ask a point where the origin of the cross section. Select that point. It will generate the cross sections along the alignment at the interval of 200 meters. It takes time. We'll wait. You can see in the bottom right corner, the sections we're creating. You can see all sections now created, right? In this, what assembly we given, based on that assembly, it will create the all cross sections, right? If we have assemblies more than one, then automatically it will take according to the stations, right? You can see here, there above is cross section. You can see drain, shoulder, median, and the ground level, right? In that, you can see the cut fill also along the cross section. In the bottom, you can see in the bottom band 0 minus 0.01. You can see this all the levels along the cross sections. Like that, all cross sections now develop. Then afterwards, the next step is define the materials. Compute the materials, not define. We defined already in the setting tab. The next step will be define the material. First of all, we will calculate the total volume required. Then after, we will go with the cross sections. In the analyze tab, you can go with the volume dashboard. Select on volume dashboard. Then this pop-up window will open. In that, select the create new volume surface. Right? Click on that. Then this pop-up window will open. In that, select volume surfaces. Base surface is existing surface, and the compare surface will be our DC bottom surface. DC bottom surface is known as the subgrade bottom surface, right? The cut factor, fill factor will be 1 only. Then click OK. Now it will generate the quantities required for hole. You can see now the quantity is generated. You can see the cut is around 23,86,516 cubic meter, and the fill around 2 crore 56,33,578 cubic meter. This much quantity will be needed for the around 50 kilometers road, right? This quantity is more. It is because we not modified the profile, right? Based on the levels, we will modify the profile, and then after the quantity will be get minimized, right? Click this icon to dismiss. Now we will compute the materials, right? Here in the analyze only, there is a compute materials. You can see this. Click on that compute material. It will ask to select the alignment and sample lines. Select that. Click OK. Now this in this pop-up window, we will select earthwork. Right? We defined already earthwork. Okay. In the earthworks, we will select cut fill, that only. In that, for the surfaces, we will select existing surface, and for datum, we will select DC bottom, design corridor DC bottom, right? Then click OK. Based on average prismoidal rule, it will generate the uh, earthwork quantities. Uh, it will take 2-3 minutes. Okay, now you can see the sections now modified. You can see some changes in color, right? That changes are they marked the earthwork quantity, that is cut fill area. You can see, I will zoom it. You can see the lines marking. You can see this much quantity we need to excavate to develop this road at the chain edge 00, right? At chain edge 200, you can see this much of quantity we need to excavate to develop this road, right? You can see likewise here we need to fill the quantity. This much quantity we need to fill to develop this cross section at chain edge 8 kilometer. Like this, all sections now generated. In the analyze tab for the quantity, we will go in the analyze tab. There is a volume report, right? Click on that volume report. Now, first of all, we need to, right? We in the setting already we done the earthwork, right? Naming was not there. That's why it is not taking. In the earthwork, I will name it as a earthwork. Same we did. Not this. In the new quantity takeoff, we added the earthwork, right? In that, we'll name it as earthwork. Okay. In the material list, we already added the existing and DC bottom surface as a base and compare. Apply that, click OK. Now we will go in the analyze tab, volume report. Right. In the volume report, we'll select the material list 1. Right. Then select the style sheet. Click on the folder icon. It will ask to select the style. For that, right now we need the earthwork. Select earthwork. These templates will be available in directly in the Civil 3D. Right? Click on the earthwork. It will open. Then select the format. Then click OK. Now you can see this will be the cutting fill statement. you can copy this and paste in the Excel. You can see at 200 meter, this much cumulative cut fill is 1,34,000 and cumulative fill will be 0. Like that, at and 200 meter intervals, they are given the all values. You can see this is basically known as a earthwork quantity, right? Now, I think everyone understood what I teach you all. If anyone have any doubts, you can ask. Right. After that, we will go with the pavement layer quantity calculation. Okay.
Hello, sir.
Yes.
Once here, sir.
Yes.
Sir, I joined late due to technical issue. Can
Your
you please
voice is
once
breaking.
elaborate quantity takeoff tab? Hello, am I audible, sir?
Yes. Yes. Please go
Hello.
ahead.
I joined late, sir, due to some technical issues.
You can
Can
watch
you
the
please elaborate
video.
once?
I will share the video on the group. You will watch the video. If you have any doubts, I will clarify afterwards.
Okay, sir. Okay. No issue, sir. Okay.
Okay. We will move to the pavement layer quantity calculation. First of all, we need to define the pavement layers. That in the setting tab, in the tool space only, in the setting tab, we will go with the quantity takeoff. In that, you will click new, right? In the information, we will name it as a pavement layer quantities. Pavement layer layers. I will name it as pavement layers. In the material list, I want quantities of subgrade GSB, DLC, PQC. As per our assemblies, we define the rigid. I will go with the rigid pavements. Right now, I need to add the 4 materials. Click on 4 times. It will add all the materials. Name the material, right? I will name PQC, DLC, GSB, and last one is the subgrade, right? In the quantity type, we will select it as a structure, right? For earthwork, we selected as a earthworks. For the quantities of layers, we need to select the structures. Right now, I selected all. Now I will click PQC. Then I want to add the corridor shapes, right? In the define material, select the data type as a corridor shape. Then in the select a corridor shape, we will select wave 1. Wave 1 is known as PQC. Then click add. Then select DLC. Then select PB wave 2 and then add. For GSB, select sub base as the layer. Then for the subgrade, we will select sub base. Like that, we added the all the layers, right? Sorry. Then click apply, click OK. The pavement layers now setting related to pavement layers we done. Right now, then we will go in the analyze tab only. We will go compute materials. Right now, we need to compute the materials of layers. Compute means it calculating of the materials, right? In that, you can see in the right bottom corner there, import another criteria, right? Click on that. In that, we named the setting pavement layers. Select that, click OK. Then this pop-up window will open. In that, we will select the object name for the PAV1 as a design corridor NG center line PAV1. Right? For PAV2, we will select PAV2. And for sub base, we will select base. You will for the sub base, we will select sub base. Then click OK. It will compute the materials. For that, I will name this as a pavement layers. For the material, I will name it as a earthwork, right? Then click apply, click OK. Now the computation of material is done. We will go for the display of materials in the analyze tab only. You can see there is a volume report. Click on that. Same, we now right now select the material list as a pavement layers. We will select that, and in the select style sheet we will select material as a style. For the pavement we need to select the select material, and for earthwork we will select for the earthwork, right? Then after click OK. Now it will generate the quantities. You can see at station wise the quantity is now generated. You can see at 200 interval this much of PQC is needed, cubic meter. It is in cubic meter. You can get the area also. Like that, all layers quantity will be there, and cumulative volume also is given here. You can see at total, I will go at the end station. Here you can see at 51,408 change, the cumulative PQC is needed 5,77,341 cubic meter. Like DLC is 2,19,771 and GSB and subgrade likewise. This is basically known as the, you can copy this and paste in the Excel. Okay, this was the quantity calculation of layers. After that, we will go, until now, if anyone have doubts, you can ask. Yes, please. If anyone no doubts, I will go further. Okay. After that, we seen the yesterday, that is the results. In the toolbox, in the tool space home, in the tool space, you will go in the toolbox. You can see in the toolbox there are report manager. Click plus icon to the report manager. You can see this much types of reports will be available in the Civil 3D, right? I will click the plus icon to the alignment. You can see in the alignment this much types of reports will be available, like that in the break line, in the corridor, in the parcel is not related to highway, pipes also is not related to highway. We will break line is also not needed. You will need alignment, corridor, and the profile and points and the surface, right? You can see in the alignment there are many types of reports. In that, I will show one or two. You can see in the station and curve, I will generate the station and curve reports. Also, PI station report, that is point of intersection stations report. I will generate station. You can right click and execute. In that, select OK. Then it will ask to save the report. I will save in the Nagpur Goa project folder only. In that, I will create new folder as a reports, right? This one is the fourth folder in the projects. In the reports, I will kept all the reports. Now it is a station. I will name it as station and curve report, right? It is selected Excel 97 2003 workbook. It is the format, file type. Then save. It will generate the station and curve report. You can see in the right bottom corner, there is a progress. If the number of curves and stations are more, it will take time. It will automatically open in the Excel after creation. Likewise, we can generate any reports in the Civil 3D. Until now, what we done related to corridor, assembly, quantity, alignment, curves, vertical curves, horizontal curves, stations, northing, easting, surface, that all reports can be generate, can will will generate in the Civil 3D. After generation, I will show you that. Until anyone have any doubts related to all classes from class 1 to class 8, if anyone have any doubts, you can ask now. Is this my audio is visible to everyone? Audible to everyone?
Yes, sir.
Then go ahead, ask doubts. If you practice, then definitely there will be doubts.
Hello. Sir, Kunal is
Yes,
here.
Kunal, go ahead.
Sir, I had three queries related to three terms. I'm not able to understand that terms. Can you please elaborate? First one is run out, run off, and degree of curvature. These are related to the horizontal curve.
Right. Okay. You can see I will show the superelevation diagram. You can see this diagram, right? I will download that. I will open. Is it visible, this diagram? Yes, Kunal.
Yes, sir. Visible.
In this you can
Yes, sir.
see.
It's visible.
In this you can see there is a curve at center where the superposition will be at the large maximum. In you can see in the first spiral length. This is a first spiral length. This is a out spiral length. This is a in spiral and this is a out spiral. Right? This superposition will be provided on the horizontal curve. Right? In this, in the spiral length, they have divided two terms, that is run out and run off. Likewise, in the out spiral also, they have defined two terms, run off and run out. Right? In that, you can see in the run out, at the starting point, there is a no super elevation, right? Only the camber slope will be there. You can see the cross section at the start point of run out. At the end point of run out of spiral out, there will be the same cross section, right? Here you can see there will be the crown cross section, only the camber slope will be there. In this, you can see uh, at the end of run out of spiral in length, there you can see in the left carriageway, the superelevation is now activated. Now the superelevation will stands to the horizontal line, right? Now in the starting point, the camber is the 2%. Now it will goes to the at the end of runoff at to the 0%, right? In the camber starting point, there is a -2% camber we provided. It will goes to the zero at the age, at the edge of runout, right? This section is known as tangent runout, right? Same in the spiral out, it will goes from the horizontal line to the camber slope, right? 0 to -2% at the outer edge of the curve carriageway, right? Outer carriageway. Then after in the runoff stage, it will now go to activate the full super illusion. Now from this point to at the end of runoff, it will activate the full super illusion, right? This is known as the runoff, and the first one is runoff. After that, there will be the full superillusion curve, and then spiral out. Likewise, it will be there. Kunal, understood?
Yes, sir. Thank you. Understood. Also, one
Another
more
doubt
question is
was,
that
wait, Shubham, we will clear the Kunal doubts first. Please go ahead, Kunal. What is your
uh,
next doubt?
yes, sir. As you messaged afternoon, there is a speed we design around
Okay,
150
expressway
kilometer per
speed
hour.
about 150 km. That's right. It is
Yes, sir.
generally we
But
design expressway for 120 as per IRC code. But if the client wants to design it with the 150 speed, then we will take that radius 2000 as a minimum radius and the spiral length as a 180 meter. That are minimum values for the 150 km. There is no IRC code related to 150 km. That's why the IIT suggested that values. We will adopt that and go with the design.
okay, sir, okay. Because I was practicing in afternoon, but I'm not able to select the 150. There was only showing 120 maximum speed for the expressway in civil 3D, sir.
Yes, yes, yes. That will be at the design alignment. When we draw the alignment, that time we will import the in the design criteria that there we will select the 150 km. We will input that, not selection. It will be input only.
Okay, sir. Okay. That means we want to design 150 per kilometer per hour. Then we have to choose radius 2000 and spiral length around 150, sir.
180.
180, sir. Sorry.
That are minimum values. Above that, any value is suitable. It is a safe.
Okay.
That are minimum
Okay.
values.
Okay.
Then
Thank you,
Shubham,
sir.
what is your doubt?
That runoff only, where it will be zero slope before runoff length.
At the runout end, there will be
Yes, sir. At runout,
end,
zero slope.
zero slope. The length of runout is 1/3, and the runoff is will be 3/4
Of
uh,
complete curve, sir. That
of transition length.
of transition.
I already given the values in the civil 3D notes. You can go through that. Runout length is important. Then anyone have any doubts?
Sir, in that assembly,
Yes,
in last lecture you have taken that crash barrier one.
yes.
Uh, in some highway they use MBCB that we have to create or it will come.
No, no. MBCB, you have to directly take the quantities. It is a length basis. Then how much length will provide the MBCB, that much you can get calculated. It is not
And
available in
sir,
this type of project.
currently in I am Karnal Ring Road. And
Hmm.
in this project, in median section, there is thriving in complete section, leaving bridge.
Yes. There will be tri-beam also, crash barrier also. According to the project, we will define the
Uh-huh.
barriers. In the civil 3D, we will create the crash barriers only, not related
और सर
with
जैसे
the.
कहीं अगर अगर रेस्ट जहाँ पे रेस्ट मीडियन प्रोवाइड करते हैं वहाँ पे
You can see in the tool palettes, there is a medians. In that, you can see the constant slope, depressed median. You can see flush with the median, median raised
सर दिस
constant
वन ना
slope. You can select this any type of median in this according to the project. Okay.
ओके
Anyone else?
सर एक ये जेनरिक लेंथ का क्राइटेरिया यूज करना थोड़ा सा बता दें जेनरिक वाला पार्ट जो है उसमें असेंबली में
Generic will be simple. You go in the tool palettes, will select the generic. Generic, in that we will select the what type of cross section we can generate in this. Now the drain will be trapezoidal shape. For the we need trapezoidal shape. For that we select the generic. If we need the rectangular drain, then also we can generate from the generic views. In that, we will select first link width and slope, right? You can give here. Now, it will disturb the results. Now, I will explain after the results. Wait few minutes. You can see now the results now generated. That is station and curve. You can see the Excel report generated. In this, you can see start, end chainage, northing, easting, is 88 plus 85. It is not 88 kilometer. It is 8 kilometer, 8 8080 8 8 8.885 kilometer, right?
8.885 8 plus 885
Yes. In like this, you can generate all the curve report by the station and curve report. After that, you can see in the tool space only. I will generate the PI station report. It will ask to save the report. In that, I will go in the Nagpur reports. Now it is a PI station report. No, I need to select the format that I need in the Excel format. PI station report. You can see now click on the create report. It will generate. You can see these all the PI points. That is the point of intersection of two tangent. You can see these they are given the northing, easting, what is the distance and direction with respect to vertical north direction. You can see the whole south 54 degree 39 minutes 8 seconds west in the coordinate in the coordinate of third coordinate. It will be in the third coordinate, right? You can see likewise they are given all PI station reports. Afterwards, we will go with the you can go through all these reports once you done the corridor and quantity. After that, you can go this. Now I will generate the incremental station elevation difference report. Right? In the I will click unselect the horizontal tangent and vertical tangent existing ground points all. Now I need at 100 200 meters. As the alignment is more, I am selecting the interval at 200 meters. You can go through if the alignment is less, you can go through at the interval of 10-15 minutes, whatever you needs. Right. Then after in the save report to, I will select the folder, same reports. then it is a FRL OGL difference report. I will select the format as Excel, then click OK. Create the report. Click on the, it will create the reports. You can see stations at 200 center to 200 distance. They are given the easting, northing, elevation of existing ground, and elevation of design. What we propose that FRL, right, and the difference. You can see this report for the whole alignment is generated. Like that, you can generate all the reports in under this. Okay, this will be all of today's class. If anyone have any doubts, you can ask. I will clear the doubt. First of all, I will clear the doubt of Shubham that related to generic.
Generic.
In that, you can see after I will delete first of all this. You can see I created the median, then the pavement layers, then I created shoulder. After that, I need
Yes.
the rectangular drain, right? For that, in the generic, we will go link width and slope. This I will click on this. Then it will ask to select the marker point to the within the assembly. I will select that. Right now, it will generate the horizontal line. There will be first bump. Bump width will be around 1 meter. I will select one, and the slope will be 0. Then click apply, click OK. Now the berm is created. Now I need the rectangular data, rectangular drain. For that, in the generic only, you will click link vertical, right? I want to link vertical. It will generate the vertical links. You can see, select link, go in the sub assembly properties. Now I need the depth around 2 meter of drain, -2. It will be downward direction. I'll select -2, then click apply, click OK. Now you can see the one side of drain now created. Now I will copy this berm and paste at the horizontal line. Now the drain width I will modify in the sub-assembly properties. Now drain width need to be 1.5. Then click apply, click OK. Now same like that I will copy the vertical and paste here. You can see I need the vertical direction. I will keep 2 as a dimension. Click OK. Now you can see the drain will be generated. After that, we will give the slope, right? In the daylight, go in the daylight general, click on that. You can see I will give the slope. Like this, the use of generic, right? I think
Okay. Thank
Shubham
you.
understood.
Yes, sir. Yes, sir. Sir, like this,
Any,
we can create median too by
yes,
generic.
you can create.
It is. Okay. Okay.
Anything you want cross-sectional, you can draw in the civil 3D by use of generic.
Okay. Thanks.
Anyone have other doubts? Please ask.
Hello, sir.
Yes.
Sir, in our stretch, if it is if I mean RE1 is coming, then how to generate this assembly, sir?
In the
I mean,
same use of generic.
we should go for generic only, sir.
Uh,
Okay, okay,
Based on
okay,
the you can give the height values in the generic,
okay,
and you can create the RE wall section also.
okay, okay, sir.
Anyone else?
Yes, yes. I have one question.
Yes.
This is Sachin. I wrongly typed Sachin. Okay.
Okay. Okay.
So I have a question not related to alignment and road,
Okay.
but related to the surface in common, like the mass excavation surface. Let's example take as example. So if I have original ground levels and I have excavated ground levels. So if
Okay.
suppose I create grid of 10 meter by 10 meter,
Okay.
and if I want to generate quantity report by grid, not as a total report, because most of the clients want that report in the grids. So how do we generate that, or otherwise, where we will cover that one, the
It is
topic?
comes under the quantity takeoff only. In that,
Mhm.
we will select the interval.
No, no, not
Generated the
this is
uh,
not related to road. This is related to like any random surface. Like let's say like 10 acre of surface is there, and there is no road,
that
no
will not
alignment.
cover in this lecture. It will be
But okay.
related to building area.
Mhm.
You can ask the
And
doubts related to highway in this class.
okay, so that won't come into this topics.
No,
Okay,
no, no, no.
okay, okay. Because I was wondering, because most of the client want that area in the grid, this thing. So by grid, how much quantity is there? So I was wondering how to create that one. So okay, anyway, this is not getting covered here. So let's stop otherwise. Okay, thank you.
Okay, we will stop now. Today is the last lecture. That's why I have taken the whole doubts. This will be the last lecture, and we will stop now. I conclude that the civil 3D classes are over. If you have any doubts afterwards or in the future, you can contact me on WhatsApp. I will give reply. I will clear the all the doubts. You can ask, and most important, practicing is very important. Without practice, you can get any doubts. If you can not get any doubts, you can't clear the design, right? So I will recommend please practice and create more doubts and clarify that doubts and become the expert in the design field, right? I will share the feedback form on the group. Please give the feedback. Okay, we will stop now. Thank you, everyone. Have a nice day and nice future. Go ahead with the
Thank you.
design field. All the best to everyone.
Thank you so much, sir.
Okay, thank you.
Thank you so much, sir.
Thank you. Thank you, sir.
We appreciate the time and effort you have put potential classes. Thank you for your interest in information. We include as we complete our scientific classes, we want to assure you that our support was not India. If you have any doubts or questions while practicing or executing scientific reports in the future, please don't hesitate to reach out to me on WhatsApp. To help us improve and refine our training programs, we would like to request your feedback. We will feedback from with you. We kindly request a comment and feedback. Thank you again for your participation and engagement. We will wish you all the best. Very fine.